Start.
Hello, everyone. Welcome to Shekru TV. Shekru TV is the agriculture extension initiative of Shekru Foundation. I'm Anand, founder of Shekru. We've been doing this for the last 5 years nearly, over 1,000 sessions on various topics in agriculture, trying to fill the gaps out there in agriculture extension. Working with various stakeholders across the ecosystem, everybody from institutions, NGOs, entrepreneurs, individuals, progressive farmers, farmers doing innovative, work out there, trying to feature them here so it benefits everybody. We're doing this biochar series with our partner 2.0 Farms. Tejas, who is the founder of 2.0 Farms, will be here shortly. This biochar series, we have done about 9 sessions so far. You're looking at the 10th, session today. We're going to be looking at small-scale biochar production with drum kilns and working with different types of biomasses out there. Dr. Sugumaran with Murugappa Chettiar Research Center in Chennai is with us today, going to be presenting on that. The center and both Dr. Sugumaran have years of experience working with multiple types of biomass and for small-scale farmers, farmer groups, and entrepreneurs that want to, make biochar with these biomass. Biochar is very happening right now. There is a lot of aspects to this, and we are very happy that somebody with the caliber and experience of Dr. Sugumaran has agreed to come to Shekru TV and present and share his knowledge, wisdom, and experience. Before I get to him, some housekeeping. This session is live in YouTube, LinkedIn, and Facebook. All those who are listening from those platforms, welcome. If you will have a question and answer session after the presentation. And then if you want to ask any questions, please do put your questions in the comment box in those 3 platforms. Those that are there with us in Zoom, please, you'll be able to unmute yourself and ask the question. So without any further delay, Dr. Sugumaran, welcome to this series. We're very happy we have you and you can share. We want you to come back since your work years of experience and we're picking a very tiny topic today and so many things we want to do. So welcome and please go ahead. Thank you.
Very short. Hi everyone. Thank you for our kind introduction about our work and our institute. I thank you, Mr. Anand Krishna, for inviting me. It's a wonderful session for all of us. So I would like to start our biochar productions topics. Next slides, please.
Maybe Ishan, you want to share the slides? Yeah.
So before going to the presentation about the biochar, I would like to share our institute. Our institute is the AMM Murugappa Chettiar Research Center. Next slide, please. So our center is recognized by the University of Madras for doing the PhD programs. Apart from that, ours is a non-profit research organization started in 1973 and registered under the Society Registration Act. Apart from that, our institute also recognized by the Scientific and Industrial Research Organization by DSAR. And we are also one of the implementing agency for CSR programs and also recognized by the National Technology Research Center like CAPAT earlier. Now we are one of the member of core group, that is core support group in DST funded projects. So we implemented a lot of projects from different funding agencies from MNRE, CSR, DST and DPT. So our institute mainly working on rural development, especially for whatever technology has been developed and taking to the rural implementation activities. Next slide, please. So coming to the this slides actually showing that almost in the 50 years old institutions, we started a lot of technology has been developed in our institute, especially in the early of 90s. We started the first earlier from years like algae-based health supplement like spirulina cultivation for health supplements, and also developed a technology called methylotrophicus for biofertilizers. And we are also cultivating some medicinal plant as a gymnema antidiabetic plants. And apart from that agricultural activities, we are also doing the engineering activities like windmill for water pumping. And older days, they are also using from HTV catamarans for fisherman groups. Like that, we developed a lot of technologies like biogas, briquettes from the energy pellets, biohydrogen, because biohydrogen from the effluent we also implemented in this technology in rural areas. And apart from that, algal CO2 sequestrations and solar cells. These are the earlier developed technologies. Now, presently, we have around 18 technology has been implemented to the rural areas, especially for the humic acid. This is for produced from the locally available resource materials like organic materials. And similarly, fortified panchakavya. This is different from the normal panchakavya. And the third one is biochar. Today we are going to talk about biochar from the different biomass. So like that, we developed around 18 different technologies with the help of some institutions or nearby uh, collaborators. And we disseminated to these technologies to the rural areas. And the next one is going forward. This is around 12 different technologies ongoing is going on, like zinc phosphate, solubilizing bacteria is going on. Then mushroom, especially in the Ganoderma lucidum, is a nutritional product, especially for the cancer activities. Like bioweedicides and water hyacinth is a liquid fertilizer like that. So we are also working on different technologies, working with the rural development, especially our institutes working with the food, energy, environment for livelihood. So this is our main motto actually. Next slide. Third slide. Yes. So before going to the biochar presentations, why do we go for the biochar and what are the problems, challenges available in the country or in the nations? So all of you know about that the major challenges in soil health management is mainly on low soil organic carbons, multi-nutrient deficiencies, less water retentions, and less microbial population in the soil, and low nutrient efficiency. And apart from that, there is a burning issues in crop residues. And also the sustainable agricultural practices like there are a lot of people using synthetic chemical fertilizers and the overuse. And apart from that, there is a soil pollution. So all are the major challenges in soil health management programs. How do you address this one? Next one. So if you take this slide, actually, if you see the global soil degradation map, you can see in India, the round we marked actually. There are a lot of areas in India, there is a soil degradation, that is soil quality is very poor actually. Due to this, a lot of areas like deforestations, industrial mining, overgrazing, overpopulation. There are a lot of causes has been taking care of soil degradations. But when we see in the graph, there is a very red color is very degraded soils. So most of the Indian soils are mostly is very degraded. So we need to take care of the soil health. Next. Especially if you take the soil nutrient status in India, this source we taken from the 2022 is a Center for Science and Environment books. When we see in the first two, it's organic carbon and nitrogen, you can see the 80% of the soil organic carbon is very less. Only the 15% of the soil is slightly good. And when we take the nitrogen also, 97% is very low. You can see the below actually when organic carbon is very low is 0.2 percentage actually. So most of the soil state below 0.25 percentage only. And some of the areas are low, so some of them are medium. Like that, some of the areas are high actually. But when compared to the soil status in the India, this too is very important for soil health management, especially for agricultural crop cultivations. Next slide. When we take the biomass waste available and burning status in India, so all of you know that there are around 170 billion metric tons biomass has been produced by annually in every year. But if you take the in India, around 500 million metric tons of India has generated as a biomass residue from different sources. When we see in the graph in the left hand side, the first one, if we started in 1950 to 1951, the blue color is actually the total crop residue is generated. But if you take the burning also, only the 18 metric ton has been burned. When we see in the graph, in the gradually, one way its waste has been generated around 500 million, that is metric ton, million ton has been generated, but Simultaneously, the biomass burning also happened in the 116 tons of biomass has been burned in every year actually. So you can see in the right hand side graph, when we see what type of biomass has been generated, majorly it was rice crops, then wheat straw, then sugar cane. And apart from these three, some of the cereals and pulses and oil seeds and cotton also we generated. So this is the general biomass generation and utilization part actually. Next one. What are the challenges for addressing this biomass availability? When we go and see the biomass, especially the paddy straw and any other biomasses, most of the biomass are loose and wet condition and bulky. It is expensive to transport and process for the applications. That's why the most of the farmers are burned in the soil itself. That is, after cultivations, they're just burned in the field itself. While field has been burned in the crop, you can see the annual nutrient losses. Approximately 3.85 metric ton of organic carbon is lost due to the burning, and similarly the 59 metric ton of nitrogen is lost, and 20 metric ton of phosphorus and 34 metric ton of potassium. So burning also, when we burning the crop, the soil nutrient also is very lost. And apart from nutrient loss, there is a problem in burning, like the decline of soil fertility, soil microbial population, and also harmful gases also released like CO2 and CO and other uh, gases also is formed. So how do you address these problems? So first one is the soil health problems. How do you address it? And second is the waste utilization part. So how do you address these problems in the country? Next one. There are a lot of methods available for improving the soil health program, because some of the people are using green manure as a crop to improve their soil health. Some of them are residue retention, because some of the people are putting residues and keeping the soil as it became fertile. Some of them are doing the crop rotation crops. Some of them are applying organic manures and vermicompost or like that. But most of the current situation, when we go and see the land in the rural areas, but organic manure or vermicompost is not available in the rural areas, because most of the people, they have lost the cattle on something because of uh, issue of the lot of issues in the villages. There is one issues, especially we can take this soil health management through the biochar. How do you that address this soil health management through the biochar? Biochar is one of the best option to improve the soil health and nutritional use efficiency in all over the world. Next one. So what everybody is asking, what is biochar? So biochar means nothing but it's a black color carbon rich porous product actually. It is produced from the waste biomass like crop residues or in the forest residues or in the wood material. So it is highly organic carbon content, resistant to the decomposition for longer years. And this has been produced through the pyrolysis method. This is one of the thermochemical conversion of biomass in the heating of biomass at least 500 to 600 degree in the absence of oxygen in the environment. It is widely used for different numerous applications. One of the application is for the soil application. There are a lot of applications are used for medicines, cosmetic, water treatment, and other applications. But we talk about only the agricultural activities. Next one. So we want to know that what is the difference between charcoal and biochar active, because these three products are available in the countries or in the market. But a lot of people are confused. What is the difference between the charcoal and biochar and activated carbon? When we see the definition, actually, when we take the charcoal, mostly the charcoal is black, the same black color solid carbon, rich material, but mostly is produced from the wood material, especially for the Prosopis julifera. And this has been used for the traditional earth clean methods and mostly used in fuel and metrology purposes. This type of charcoal is currently available in the rural areas, but they will use it only for the fuel purposes. But when we take it to the biochar, actually, biochar is a carbon-rich porous material and derived from the biomass. So when we see the charcoal and biochar, it will be used from the only biomass-based materials called biochar. But if you take the wood materials called charcoal, but this has been biochar has been produced through the modern slow pyrolysis kilns. like drum methods or any other modern technology has been used in the slow paralysis techniques and below 500-degree temperatures actually. And especially this has been used for the soil amendment and bioremediation programs. But if you go to the activated carbon, this too is different from the activated carbon because activated carbon is rich in carbon material and highly porous structures. This has been mostly used from the coconut shell material. Most of the activated carbon is produced through the coconut shells or the peat and coal. But it's pyrolyzed in the fast pyrolysis techniques with the steam activation or the chemical activation in the higher temperatures. More than 600 to 1000 degree, they have to pass the temperature or the steam. It will create a lot of pores and create a surface area, higher surface area, and has been used for the wastewater treatment, especially when we use the drinking water or something purifications and solvent recovery and medicines. So these are the differences between charcoal and biochar and activated carbons definitions. Next one. What are the methodology that is used for the biochar productions? In the worldwide, they are using different techniques on methodology has been used, but most of the methods they can use it for in the country. But these three products is mainly come out from the process, especially for the thermochemical of conversion. The first one is gas and liquid and solid. You can see that there are a lot of methods available. If you take the torrefaction, traditional slow pyrolysis techniques, and fast pyrolysis, gasification, and modern slurry. So each having some different temperatures and residence times, you can get the bio oil. If you want a purification, you can get biochar for more biochar 80%. If you go for the gas method, you can go for the gasification because gas has been converted into energy and energy has been used for the any other applications in the industry. But we want biochar by using the biomass in the low temperature. That's why we selected the modern slow pyrolysis techniques around 400 to 600 degree temperature. But the residence time is maximum is 1 hour or 1.5 hours something. Then you can get around 30% of the biochar yield. But mostly syngas has been come out actually. These methods of slow pyrolysis techniques. Next one. Before. So there are a lot of biochar making methods available in the country because earlier days they will dig up one small pit and put it on the biomass and burn it actually. During the burning, it converted into a thermal energy and converted it to like char material. They just sprinkle the water and off the material, you can get the biochar. Similarly, drum method and cone taking. So this is also when we compare to simple biochar making methods available. If we go to the soil pit method, it's a crude method, but low quality material you can come out. When we do the soil pit method, the carbon content or the your material will be low quality and inconsistent material will be obtained. And also high emission of heavy smoke like CO2 and CH4 has been released. But this technique is very low cost, labor intensive and inefficient. But it is not scalable and suitable for temporary uses. That's why the soil pit method is not applicable for the most of the parameters is not applicable to the soil application. But when we go to the drum cleans and the cone taking method, the closed metal drum with the limited oxygen exert, it will give you a good carbon content around 75 to 80% of the carbon content and quality also good. But the medium emission will be come out through this drum method cleans. And if we take the cost, very low cost method because we are using the old oil drums converted into this type of biochar production methods. And it will be very useful for the small farm holders for the decentralized biochar production because when we use this drum clean, we can provide as many farmers can as many because the cost around 5,000 to 6,000 rupees for the clean cost. So most of the farmers they can prefer for own purpose, then they can use it for the soils. But if you go for the Kontiki method, actually, this method is called conical metal open cleans. This is also a batch type actually. This technology is the film curtain limits on oxygen environment. And mostly this is high quality carbon, 70 to 80% of the carbon content and medium consistence. And this will give very minimum emission from the carbonization process. and also relatively safer and expected for the carbon credit people. So most of the carbon credit agencies, they will recommend it for this cone tiki method due to the less emissions and good carbon content. That's why in all over India, the cone tiki is recommended for the carbon credit and other activities. But when we compare to the drum clean and cone tiki, if we go for cone tiki, you have to stand and you have to put the biomass continuously. But if you go for the drum method, you just fill it and you can go for the any other works. Because when we do this type of experiment in our centers, the drum methods, if you fill it one time, batch time, it will take, depend upon the biomass structure, it will come to some of the material like leafy material, it will come to 30 to 40 minutes, it will carbonize. If you go for the wood material, it will take 1.5 hours to 2 hours for carbonizations. But if you go for the cone tiki method, you have to stand the cone tiki near to, then you have to slowly you can add the layer by layer method actually. Because in farmer point of view, they will do actually they will do the farm work and they will come and take after 1.5 hours in our model. But if you go for the cone tiki model, you have to stand and watch the material. If not giving some 10 to 15 minutes, it will come to ash content. So you have to control, you have to see the material, then you have to put the biomass continuously and take it to the upper level, then you have to take it. So that is the difference with drum method and cone tiki methods actually. Next one. These are the small type of portable cleans are available in the world. Some of them are vertical models, some of them are horizontal models available. Some of them are multi-drum model also available. We also tried multi-drum. I will show you our method also. These type of photographs available in the country. So most of the people over once they are easy to produce, they will make it their own cleans actually. They are not bothered about the cost or and or the technique or something. They want finally they want biochar. So that's why this type of cleans has been developed. Next. This is for continuous biochar reactor. The first one is Takachar. I think you heard about one of the gentlemen from Delhi has developed this technology. There is very 99% is emission free, and this is for mobile unit. So wherever we go, we can take this mobile unit and do in the field itself. The second one is the static model. This is also is the continuous production models. And the third one, the left hand side, PU is also they developed a screw type of biochar reactors by using the paddy straw pellets into biochar. The another one also small scale biochar production unit by developed by the some of the company actually. So in the country there are a lot of continuous biochar reactors is available, but each one is having different cost economics. If we take for Takacha, maybe 25 to 30 lakhs for at least 500 tons per day. Like that, if you go for the higher scale, maximum 50 lakhs, 75 lakhs like that is available. But our institute is very low cost method has been developed to taking care of the soil health and also the farmer friendly methods. Next one. So what are the development of biochar over the years? Coming to our MCRC activities, initially in 2006 to 8, we started this biochar as an energy pellet. Generally, we started energy pellet from the local available biomass, especially when we go and see in the Chennai regions, in a lot of coastal areas, a lot of the casuarina plantation is available. So we thought that we can utilize this leaf litter because when we go and see the leaf litter, they will not decompose easily because the lignin content is very high. So during the 2006 and 8, we developed this biomass has been converted into energy pellet for cooking uses, especially for the rural villages or in the hotels or something with the help of DST funded project. After that energy pellet preparations, we also used for different agro wasters or in the material for them to convert activated carbon from the biomass because generally activated carbon produced from the coconut shells. But we tried in the activated carbon in the biomass itself, and we can develop a small scale water purification system in our centers. This is for slow sand water filtration by using activated carbon by our methods. This is also implemented after the project. We implemented more than 200 of water filter unit to the tribal communities by using our activated carbon for water purification purpose. And after that, why don't you use this type of biochar for soil application? We started in 2013 to 15. Generally, we can use it for this type of biochar for the soil application for the organic carbon improvement program, especially in the pilot scale levels. Then we moved to why don't you apply biochar with some compost or vermicompost trial. Then we moved to why don't you try with chemical fertilizers to use increase the use efficiency like that we tried. So these are the over the period we developed one by one that biochar has been happened. Now we come to this some stage actually. Now we developed this technology and we apply to different methodology by using by the farmers. For example, if low organic carbon soil, we can recommend it 5 tons per hectare for biochar for soil amendment. Suppose if we want to mix with biochar or the vermicompost, we can recommend it 1:1 ratio for especially for 2 tons per acre, or some of the carbon content is very low, we can recommend a higher also. And now, because universally most of the farmers are using urea as a universal for urea as the main material for application of agriculture, we told that to reduce the urea application by mixing with urea and biochar to improve the nitrogen use efficiency. This has been validated with the ICR Institute. I can show you the results also. Next one. So when we see in our biochar process model, same thing, you have to collect the biomass, just whatever the leaves or husk or wood or nutshell. Just if not dried, you have to dry for 2 or 3 days. Then you have to manual separation because we cannot put all the biomass into one single kiln, that is a drum method to make it biochar, because each material having different nature. If you put leaves means it will come within 30 to 40 minutes, or in the 15 minutes you can come to the charcoal. So we have to separate the biomass, then you can use it for the biochar making. So in the slow pyrolysis technique, we are using the old oil drum has been converted, then hold it, take it to the biochar and dry it. Finishing, we have to pack it and selling to the rural markets. Next one. So we decided actually, we divided into 2 categories. Generally, the soft nature materials, less lignin content materials, log, leaves, fibers, husk and straw materials called the soft nature materials. Hard nature materials like high lignin content like nutshells or wood chips or in the wood material, we can divide it. So wherever we go and talk to the farmers, we have to just inform that very less thin material, you can use it for 30 to 40 minutes within, you can convert it into biochar. But if you have hard nature material like nutshell or the wood materials like that, it will take 1.5 hours to 2 hours of biochar productions. Next one. We tried actually through our project, we nearly around 65 different biomass has been collected from the local areas. We just do all the activity, whatever the scientific approach, what are the biochemical parameters, proximity analysis and ultimate, and also the thermochrometric like temperature making major biochar productions, and also physicochemical parameters of the biochar. So like that, and each biomass, around 65 different biomass has been collected and characterized based of the scientific approach. We have a database of the biochars. Next. So what are the major achievement of biochar production? So I already told that around 65 different biomass are scientifically evaluated for biochar. And we also do the production time and yield application, that is yield optimized. What type of material we can use it and what is the temperature time is required and what are the yield also. We developed a pilot scale chart sheets actually. And apart from that, we also do the decentralized biochar productions. We train the local peoples and providers this type of drums in the low cost. Then they will produce, and some of the areas we can create a local level entrepreneurs, and we can buy from the CSR project and distribute it to the rural poor people to popularize our biochar. Next one. I told him this is our small scale around 200 liters oil drum has been converted into that clean fabrication. So you can see the specifications. If anybody wants for fabrication of this clean, definitely we will share this diagram or in the video. You can make it in our own place within 2 to 3 hours, because this is not a very complicated one. Only the oil drum you have to cut down in the bottom. You have to make it small door like that for the air circulations. And the bottom small mesh has been provided for holding the biomass. Then one chimney is lid with chimney will be provided. Very, very simple, with easy to fabricate in local areas wherever the welders or the fabrication center is there. You can use it. No electricity is required. Only small biomass. Just put it on the door. Then you can start the burning process. Once the 5 to 10 minutes is the burning will happen to the biomass, you have to close all the drums and the lid also. Then you can watch the chimney. Initially there is a smoke will come. After the burning and conversion is happened, is completed, there is no any smoke will happen. That is the indication. You just sprinkle the water and take the biochar. Next one. So we tried, this is a 15 liter, 15 kg of capacity, 25 liter capacity, 50. There are a lot of different methods and some modification has been some SS material also we use, some MS material used, and moving time. So depend upon the farmer interest, we have to put the materials, because some farmers are interested for only low cost around 2,000, 3,000, 4,000 for type of drums. That's why we recommended old oil drum. But some the big farmers, we have to long lasting material. They can use it for SS or the MS materials also. But finally, when we come to the depend upon the clean and pyrolysis temperature and time, that biochar yield also is different. But most of the char yield, if you take that leaves fibers and straw materials, around 25 to 30 percentage of the biochar yield. When you go to the nutshell or the sawdust or the wood biomass, it will take 2 to 3 hours of pyrolysis time, maybe some 35 to 40. Because depend upon the biomass nature, the char yield also is differ actually, especially the temperature and time also is playing the role for the quality of the biochar. Next one. This is a model we actually developed MCRC. Next one I can show you. Next one. This is the first model actually when we do in the 2006 and 8, we developed this type of method actually. Because one bigger drum and you can put the smaller drum, we just fill the biomass in the inside of the small drum actually. But when we do this type of method, we have to put lot of biomass for burning in between the small drums. So lot of waste has been burned and get the ash. But inside the drum, it will take to carbonize very long time. So this is the interference we reported from this type of multi-drum biochar cleans. Then only we modified it to single drum method actually. Next one. This is a simple drums. When we take the old oil drums, we just put it in the lid and chimney and providing small door in the lower side. Then we just put small amount of biomass and just burn it and close all the drums. The burning process will start up from bottom to the up. Once the biomass has been carbonized, there is no any smoke will arise. Then that is the indication we will take the biochar. Next one. This is one of the method called tilting as well as the moving method actually. When we see in the, because lot of farmers ask one place to, because they cannot take the biomass one place to another place. This cost wise is very economical wise very higher. That's why they ask the moving methods, and people are all told that when we doing the carbonization heat method, they will not touch the drum actually because of the high heat. That's why we put the tilting method of the drum methods. We use this type of technique in small one of the farmers field. We tried different biomass also. We got a very good results, and we got a very good biochar also actually. Next one. This is the another myth, because some people are told that why don't you arrest the fumes, because a lot of smoke will be come out from the burning process during that initial time. How do you address this like that? That's why we put a small pipe and put it in the some scrubber materials, and we started this experiment in the one of the farmers field. So most of this type of techniques are we tried in the experimental purpose only, because this is all the very expensive method. When you put the tilting method or moving method, definitely the cost will not higher actually. Sorry, cost is will be very higher, because only the small drums cost will be 5,000. If you go for tilting and other method, it will come to 35 to 40,000 rupees. Is all together actually. That's why most of the farmers, small farmers, not interested this type of techniques. Only they use for the small drums. Next one. This is the horizontal model of drums actually we developed more recently actually, because when we do in the pyrolysis in the vertical models, they have the height and some issues. They have wanted to horizontal type of models. We also developed the horizontal type of biochar kilns and make it for biochar making. This method also is very good actually. We got a very good results for biochar productions. So maybe this is also when we use the old oil drum, some of them are using the MS sheet based material also. Because if anybody wants this type of cleans with horizontal model or in the vertical model or in the uh, gas controlling techniques or something, definitely we will come and help you for these techniques actually. Next one. But finally, we recommended for, because we work for only the poor and marginalized farmers. That's why we recommended small scale, that 200 liters oil drum methods only. We cannot go for the tilting method. This is also one of the simple tilting techniques where has been used. But most of the farmers, if you go for tilting and other things, the cost will be slightly higher. But we wanted to know that depend upon the farmer interest, we will fabricate and provide it. When we see this the photographs, we can use it for different type of material, like corn cob has been used, some fiber materials, some leafy materials, and some hardwood material also we can use it for biochar makings. Next one. So you can see this is the small photograph, but we have 65 different biomass to biochar photos actually. Only the small portion we have showed that, but we have 65 different biochar material also. When we do the biochar, the same shape and other thing will come out from the biochar, because they cannot come out from any powder form. If we put the coconut fronds, the same shape will be come out. Then only we have to crush it and make it as a powder. Next one. So finally, what we do now, actually every year we produce annually at the rate of approximately 500 to 600 metric ton by using the local farmers, because we provided each locations are 10 to 15 different drums to the farmers. Each farmers has been produced and they will hand over to the one main producer. Like you know that the milk procurement center methods actually. So each farmer they will produce monthly averagely around 500 to 1000 kg of biomass, sorry biochar. Then hand over to the main producer and we will provide the order to the main producer. We will buy from the biochar, then we distributed to the different farmers for the application of soils or other urea mixed biochar applications also. Next slide. So what are the major quality parameters of biochar? When we buy or when we use the biochar, this is the main parameters recommended by all the biochar agencies, especially the most of the biochar pHs, mostly is alkaline materials, and also the water holding capacity is more than 300 to 400 percent white. Then the fixed carbon will be more than 50% is recommended for soil applications. And apart from that, the H by C and O by C. So this is very, very important for when we do the soil application of biochar. Fixed carbon, then biochar stability. So below zero point 0.4 and below 0.6 is a very good stability for the soil application. So most of the references as well as the European standards or the IBA standards told that the biochar stability will be below 0.4 and below 0.6 actually. And apart from that, a lot of cation exchange capacity available. Then also we want to know that what are the nutrient contents available, macro and micro also. But apart from this, we also tested some surface area and porous structures for our research purpose actually. Next one. This is the stability, what I told, no? When we see in the H by C ratio and Y by C ratio, you can see that if you put the biomass, it's very high. When we come to the charcoal or in the char, you can see the differences for aromaticity. That's why the highly aromatic condition of 0.4, below 0.4. That's why we recommended for highly aromatic materials. So most of the biochar will be highly aromatic conditions only. Next one. And apart from that, you can see that, sorry, 1 second. When we apply why the biochar stability has been tested means, depend upon the O by C, it will long lasting for the soils. If you see the above 0.2 is highly stable for 1,000 years. This is recommended by the research papers. If the 0.2 to 0.6 moderately stable for 100 to 1,000 years. And above 0.6 relatively unstable, maybe 50 to 100 years. So depend upon the O by C ratio only, the biomass, the biochar will be stable in the soils. Next one. We also tested a lot of some sample test has been provided. You can see the fixed carbon content by using our techniques, drum method techniques. Most of the biomass comes around above 50%. Our methods actually. So when we see in the prosopis wood or coconut fronds or maize cob, whatever the local material, because in our area, some farmers are cultivating mainly on maize. That's why they put maize cobs. Some of them are using corn cultivation, maybe corn stalks also. Some of them are using tea plant in the tea estates. They're using tea plant prunings. So like that, whatever the waste has been generated, they will produce and they will test it in the laboratory. Then we will make it to applications. Next one. This is also nutrient content. The sample, what are we showing you? Only the small sample only. We have around 65 different data bases available in our office actually. When we see in the paddy straw or the coconut fronds or tea plant pruning or wood charcoal, there are a lot of nutrients is available. But if you take the total nitrogen or phosphate or potassium, very, very less. That's why the people are telling that don't use biochar alone actually. Biochar is not a fertilizer actually. This is a soil conditioner. And when we mix it with any material or any mixing with any biofertilizer, it will give the very good results or in the compost like that. Okay. So when we applications, you cannot apply alone. That's a biochar. That is our recommendation also. Next one. Actually, MCR has developed 3 different techniques also. You can see the first one, we started in the biochar for soil alone because we 5 tons per hectare actually poor soils because some of the areas they are not cultivating more than 10 years or 15 years. They, the soil quality is very, very, very poor. That's why we recommended for only biochar for soil amendment. Before plowing the soil, you just spread the biochar, then you can plow it, then make a cultivations. This is for the poor soils, very, very poor soils. But if the soil is continuously cultivating some moderate level organic carbon is available, then we can recommend it to compost or vermicompost, mix it, just keep it for a week or the 10 days to just making enriched material, then you can apply. The third one is you mixed biochar mix urea application. This is the new method we developed actually. We can use it because universally farmers are using urea as the main material for agriculture. We thought that we can reduce the urea, then we can make it as a nitrogen use efficiency because you know that the urea has been applied to the soil, immediately is evaporated or leached out. But our techniques, if we mix it and keep it in for 6 hours in the airtight container, then you can apply to the soil. You can nitrogen use efficiency will be improved. This was validated by our ICR institution. Like we validated this technology with 4 different institutions like Indian Rice Research Institute, Indian Oilseed Research Institute, and Punjab Agriculture University, and also our Tamil Nadu universities. So 4 different university has been validated these techniques when we reduce the urea quantity by 25%, giving the very good results. So they are not putting 100 kg of biochar, they just putting only 75 kg is enough. Then we mixing 25% of biochar. So I can show you the results also next. You can see the below one is photograph below. You can see the lot of improvement in the soil as well as the crops also. Next one. These are our experimental various crops. Actually, we developed in paddy. We tested sesame crop, chili. These are the soil applications generally. 5 tons per hectare like that. Some photographs. And then the last one is in the tea plantation. We can put the same tea plantation, tea improvement also. So these are the some photographs we can show you, and results also I can show you the next one. So we tried in the planted tree plants also. When we use it for lemon trees or coconut or mango, we just applied with vermicompost or in the compost farmyard manure like that. Just applied, and we get a very good results and growth as well as the yield also. Because one of the coconut plantation is more than 25 years. It was in the worst conditions. But when we applied in the biochar with the compost, now it's a very good yielding of coconuts actually. We got a good results. So we also recommended this biochar with compost or biochar with any biofertilizer applications also. Next one. This is the one I told actually. We have tested this urea mixed biochar validation through the government research institutions. I told him 4 different prominent institution has been used, and 3 different crops actually. Paddy, wheat, and sesame also we developed actually. Next one. So you can see this urea biochar validation at the ICR institutions developed actually. 3 seasons they used the same type of soils. They can mix it with 100% urea and 75% urea with 75% BG. When we compare the graph, you can see that the control versus the T1, almost the similar yield, 13 and 12 is not a much different actually. So the recommended by the oilseed research institution by the sesame crop, they recommended 75%, 25% biochar yielded. When compared to 100% urea recorded the comparable yields, there is no any significant difference was observed by the experiments. They said actually they can reduce the 20% urea in the sesame cultivation. They will provide the certificates also. Next one. And this is the nitrogen uptake in the soils. Because when we reduce the quantity and apply to the soil, you can see that biochar applied soils, they got a very good absorption of nitrogen uptake by the plants. Okay. So this is also done by the ICR and IOR institutions. Next one. And similarly, paddy crop, actually 3 seasons they are applied in the same field and same conditions, same experimental did in the Indian Institute of Rice Research at Hyderabad actually. In the 75-25, you can see there is no any significant differences when compared to the control. And also they use 2 type of biochars, because some people are told different biochar giving different yields. But when we use the 2 different type of biochar, rice straw biochar and the coconut husk biochar, there is nothing significant. If you see the rice straw, they can yield 5.67. Maybe if you use the coconut husk biochar, only 5.34 or 5.467. So almost similar yield pattern has been observed. So nothing different between the biochar, between the one biochar to another biochars. So they also recommended that 75-25% giving the good results. They also told that recommended to reduce the urea in the paddy crop. Maybe you can mix it 25% biochar giving the good results, especially the yield and also some nutrient uptake with all the 3 seasons. Next. And similarly, you can see this graph also, the N applied and plant uptake in the experiments. When we low quantity of urea applied, but take a higher amount of nitrogen by the plant, because the plant will uptake nitrogen will be more due to the biochar has been giving the more nitrogen to the plant. Because of slow nitrogen releasing patterns will be observed. Next one. This is also one of the university, Annapal University. I think so, you know that.
I just wanted to interrupt here a little bit, just doing a time check.
Yeah, I will close it. Yeah,
I
please.
think we'll come back to this as a separate session because there is
Yeah.
so much going on here, and this is some wonderful work you've done.
Yes.
Can we speed up
No,
here?
I think just 5 minutes. I will close it.
All right, sounds good. Because we really want to go deep at this, but maybe in a separate session because there is a lot of things coming at us, and it's wonderful.
Yeah.
Yeah.
So this is also did with our Annapal Institute. We got a same result, but this experiment is entirely different from all other institutions because this experiment is giving the higher yield when compared with the 100% urea. You can see that the 100% urea, when we see in the 25% reduced urea, 20%, some percentage around increase the yield of the yield in the paddy crop. Next one. Same the nitrogen pattern. Next one. And this is by Punjab Agricultural University. They did the wheat crop actually. You can see the differences also. When we see the control and the 80 and 20%, we see the similar pattern also is observed. So all the four institutions recommended that when we reduce 25 to 30% of urea, you can get very good same results by using biochar because biochar having the capacity to absorb the nitrogen to increase the efficiency in the crops. Next one. Same, this is the paddy yield actually. Next one. So this is the overall summary of the urea batch experimented by the each institutions. So whatever the application I told him, so 25% definitely if you reduce by urea, you can get the same results, no yield reductions, but also a very good environmental friendly method by using the biochar techniques. Next one. This is a key mechanism when we use the biochars because some people are asking what is the mechanism involved in urea mixed biochar. You can see they reduce the ammonium volatilizations and buffer the soil pH and retain the nitrate and the ammoniums and enhances microbial habitats and improve the soil structures. So these are the success of UBC. Next one. Apart from that, we also talk to the farmers point of you can see the differences also. We tried in more than 5,000 farmers. One is urea mixed bias application, one is the 100% urea applications. They got a very good results in the farmers field also. But when we talk to the farmers, we told that because urea getting it's a subsidized price because urea is getting 300 rupees 45 kg of bag. But if the original price is more than 2,700 rupees of 50, that is 45 kg of the urea. So we told them don't use so much of urea and so much of money is wasted by the farmers as well as the government. That's why we put a small table column because if you take the farmer point of view, if you use the 600 farmers, at least 30 tons of biochar, the farmer itself they can reduce around 27 metric ton of urea has been reduced, and also the cost has been 1.8 lakhs reduced by the saved by the farmers, but the subsidy also is mostly saved because this is the projected by the government because we talk to the policy makers and other things. Don't use so much of urea because they're putting a lot of urea to the soil because of the subsidies. So we uh, told the farmers don't use the urea. You can use it for biochar. It will give dual purposes. One is the soil health improvement. The another one is the nitrogen use efficiency programs. Next one. Last slide, I think. Some of these are the small scale biochar units entrepreneurs opportunity. We work with the different states actually with farmer FEOs and its NGOs also. This technology has been demonstrated on trained by the people in different locations. And through this development program, we developed around 39 entrepreneurs, small scale entrepreneurs in different locations also. Next one. You can see this is the popularization of our method techniques in different states with local NGOs. You can see the Bihar with some of the Ajivika NGOs and Odisha, Sabha like that. Different around 4 or 5 states we working with the NGOs one. Next one. This is the opportunities actually. So we can provide the supporting for entrepreneurship making, hands-on training, support the business setups. We provided the clean fabrication as well as training and everything. And finally, we will provide some market independence. For first time, we will provide the free of cost. We will buy the biochar and put it to the farmers at the free of cost. Then second year onwards, they will make the money actually. Like that, we have some program under the CSR program. Next one. So these are some of the photographs we tried with the different areas actually. Next one. So this is as repeated. Sorry, next one. Last slide, I think. This is the last slide actually. However, we have some key challenges and way forwarded because everybody talking about the feedstock availability and affordability and sustainable biomass feedstock. Because some people are told biomass available, but some people are told there is no any not biomass because competition with the other uses like fuel, fodder, and other uses. So this is the some challenges in feedstock also, and apart from the technology and production also, because when we do the high operation and production cost, most of the biochar currently we have there is the cost base is very higher. That's why the people, the farmers are unable to afford the biochar in the agriculture uses. Because we purchase this biochar at least 10 to 12 rupees per kg. If you go for 10 to 12 rupees if you take the 50 kg bag, at least 500 to 600 rupees. But farmers told that urea getting 300 rupees price. They will match the urea price with the biochar price. But ultimately, the biochar price will be higher, but benefit is very, very higher when compared to the urea and other things. And apart from that, the lack of research development, because most of the people told that different soil crops and validation also is very lacking in the research and development programs. And apart from that, the government policy regulations also we have to support. When we do this type of biochar with a higher cost, maybe government is supporting as a subsidized price. Maybe government is subsidized by 50%. Definitely, this will go to the very good promotion of biochar to all over the India. And market challenge is also available because this is a new product and people are not aware about this product of biochar and for soil application. So these are some key challenges and way forwarded in our work. Next. I think this is the last year. So thank you so much for our patience, and I would like to thank Sekru and Anand Krishna sir and everybody for this is giving the opportunity, very good opportunity to talk about this biochar to all over the people. So thank you so much, sir. If any questions or clarifications, I'm happy to discuss with you.
Thanks a lot, Sugumaran sir. It has been our pleasure, wonderful opportunity to learn through and hear through decades of experience, actually. There's a lot of information coming our way. I think that's what Anant also...
Actually, a lot of other that scientific data is available, but unfortunately, we cannot show all the data in the same small time intervals.
A lot of exciting work. We would love to go deeper and deeper because every slide you covered, there are a lot of depth that can be gone into.
Thank you so much. Yeah.
Anant, any early thoughts on the tsunami of information that has come our way?
You go ahead with the questions. I have about 5 or 6 questions I've prepared, but you get to go first.
Wonderful. So one question I had, because this was also there in one of our Biochar Crusaders group. So I wanted to ask, in the kiln that you have, how does the flame and air move in this drum kiln setup where, and is it a top lit or a bottom, say, top lit?
Actually, our method is the bottom approach actually. We have given the small doors in the bottom. No, two sides there is some small doors will be there. That is the air circulation to improve the pyrolysis techniques. Actually, we just burn it in the lower side. The lower the flame will be go to the top, and they will go to the upper sides. So ours is the bottom side approach. So if you go for the fast pyrolysis technique, you just open the lid. The air will be go very fast. The burning process will also taken very fast.
So you rightly compared the soil pit, your drum, and
the quantity. Yes.
How would you compare this with a top lift updraft system, TLUD system?
Actually, our method is almost the TLOD method one.
Okay, but
The
there
drum.
the light flame is coming from top to bottom. If I'm
Yes, but we just modified small method actually. That's why we put a lower. Everybody they're using their own uses. So we also thought that why don't you use the simple techniques by using the upper side to the top side actually. But in the almost the similar technique has been used for the TLUD stuffs one. Initially, but we use it for TLUD. Then only we modified this one actually.
I think I had one question which you answered probably at the end a little bit. You said there are a lot of farmers producing biochar and almost like 500 to 1000 kgs a month,
In a month. Yeah.
bringing it like a milk procurement system to a bigger,
Yes.
larger farmer who probably is converting this into the right compost uh,
Exactly.
and then be able to sell it. So how has this been so far, sir? And how many numbers have these farmers able to
Sir,
start?
actually, in around in Tamil Nadu, is around 39 producers will be there. This 39 is converted into 4 or 5 main producers actually. In
Hmm.
each village, we provided around 10 to 15 drums for the single drums to the each farmers actually. The farmers will produce biochar and store it one place. On monthly basis, they will hand over to the main producers. The
Hmm.
main producer will note down the name and what out the cages they will produce. Then, if we provide the order to the main producer like 10 tons per the producer. He can collect the biochars and make it in the uniform size of biochar because we cannot put the uh, bigger materials because they will not go to the one portion to another portion. We make it in the powder form, it will spread all over the soils actually. So we can make the uniform size, then make it is a small bag like urea like bags, printed bags, and stitch it and provide to the farmers. This
So,
is happening in the villages actually.
so
But it
we
will cost if you put this type of for production to end of the packing, the cost will be around 12 rupees, maximum 12 rupees we buy.
12 rupees a kg
12 rupees per kg.
is the final product cost,
Yes, final packing cost actually, selling cost.
final
But
selling.
the original cost will be maybe 8 to 9 rupees or some of them are 10 rupees because some people are going to buy the biomass and burn it in the biochar. But our method don't buy the biomass actually.
Hmm.
Whatever biomass having their own farm, they can make the money. If I am cultivating maize crop, the after maize harvesting, there is a cob is available. No? I
Hmm.
just make a cob as a cost. We can make a biochar, then we can make a cost tax. Small cost may be used for the making of biochar,
Makes sense.
like that. So, but some people told that I will make more biochar. They will go and buy from the outside and make it, but that's not a cost economics. Very very uh, actually high because
So
when we go and buy the biomass and make it biochar, it will cost up to 20 rupees per kg or 25 rupees per kg
I hope.
because biomass cost is around 2000 to 3000 rupees. Then transport cost will be there. Then making cost will be there. But in the own production, there is no any collection or something. Whatever they available, they can make it and put it to the back and give it to the main producers.
You're wonderfully almost taking this to a commoditization.
Yes.
That's really interesting. One question I had was you talked about different parameters that you tested in various of your biochars.
Yes.
You took us through all the different metrics, pH.
Parameters.
And I had one question around cation exchange capacity,
Yes.
CEC. How is
Yes.
it measured? How did you measure it? And you also touched upon measurements of surface area and porosity in research. Can you please shed some light on these three?
Actually, if we go for the cation exchange capacity, this is the biochemical parameters we can do in the laboratory itself. Our own laboratory, we have cation exchange capacity. We
Hmm.
have some procedure will be there, standard
Oh,
procedures. You can also do some chemicals also required. You can make it own cation exchange capacity. That is not a very big issues.
surface area and
But if
porosity.
you go for the surface area and porosity or something, you have to spend a single sample at least 5,000 to 10,000 rupees. But not necessary for the porosity or surface area for the soil applications. But if you go for the water treatment or any effluent treatment like that, you have to study the porosity and surface area and iodine number also. Depend upon the application point of view, you can take it. If you go for soil, you have to study the carbon content and carbon stability. That is very, very important actually. Because above 50% is recommended by the European standard or IBA standard also. Similarly, in the fixed carbons also, and stability.
And what is the cost of production for them? And you're talking about a lot of decentralized model where the farmer that the feedstock that he has access to, he'll turn it into this. But will it remain like this, or do you see this also turning into a model where people have to go out and collect from these farmers because farmers have lesser and lesser time on their hands? We have lesser and lesser people in the farms nowadays. So
Sir,
how do
actually, first time they will provide the free. For example, one farmer go and buy from take from the other farmer, they will provide free of cost in the first time. But when we make the money by the farmer, they will know that he can take my biomass and convert it into biochar. He will make the money. Then only he realized that why don't I also take biomass and convert it to biochar. So people are thinking that if we got money, some money from the personally, then they realize. But
So
people,
in a way, you are actually doing your own monitoring, reporting, verification, almost like uh, almost in the milk value chain
yes,
there.
yes.
But have you also been approached or tried out the other angle of this, which nowadays is the carbon credits and trying to bring co-benefits? So have you been able to unlock
Yes, sir.
carbon
Actually,
credit?
a very good question you're asking because so many people are talking about carbon credits on something. When we approach the carbon credit people, we have to register itself. We have to pay the more money actually, registration or something. But our institutes are not willing to make the carbon credit or something because of registry and some other issues. We cannot go for the carbon credit. But we tried actually, but
Anything
not
with
yet
the
done.
recent green credits that were announced? Any progress there? Indian regulation?
Yes, lot of people are is there. European, some other different people are doing the carbon credits. We tried some of the agencies like Carbon Impact Capital or something, but registration, other thing, they have put some of monitoring system. When we do the pyrolysis technique, also they want to know the photographs, what type of biomass used, how to take everything. They have to capture it. The DMRV, some software has been used. But in the farmer, they cannot do such kind of activities. But if we do the any small scale industry, they can do because our main aim is farmer can do the biochar. They can do the develop a health parameters in their own method actually.
One last question, which I think Anand also touched upon when he introduced you, is you have done a lot of things at MCRC that biochar is just one aspect.
Now, yes.
How important aspect do you see biochar to be so far and going forward
So
among all?
biochar, I think is very very important for the nowadays and also future actually.
Hmm.
But most of the people, most of the country people, everybody is doing the biochar research. When we go and see the any universities or the colleges or anybody, definitely one of the people they said, I am also working on biochar. So we want to collaborate and we want to do with like we want to study all the parameters. Then only they can that our India also or in the countries also they can develop because biochar is a very good material to help improve the soil health as well as the nutrient use efficiency in the fertilizers also.
The work on urea is amazing, but I think
Yes,
in the
thank
interest
you.
of time,
Yeah,
uh,
yeah.
I'll those who are watching from whichever platform, you can leave your questions on the chat windows, and Bibhishan will help
Yes,
collect.
yes. Otherwise, I can help you for any questions personally. If you want, my number also I can share with you. Anybody wants the questions or clarification, I will share the answers also. No issues.
Anant, you want to jump
Yeah,
in?
yeah. So Bibhishan, please feel free to interrupt if you have any questions coming from the three platforms.
Yes.
The questions I had, Bibhishan, can you show the bin slide if you don't mind? The bin, the drum bin. So, doctor, I had a question on how many times can you burn this bin? How many times will the metal last? I mean, is it
Exact correct question, sir. You're asking. You only ask the same. Actually, sir. Actually, when we do the oil drums, maximum is 3 to 4 months will be validity. That is stability, because heat and cold, the drum will be lost within a 4 to 5 months itself. They
right?
cannot make more than 6 months actually. For example, if you do the paralysis in the drum per day, maximum 3 to 4 batches per day. If you take the monthly, maybe 25 to 25, maximum 20 to 25 batches, 25 days only we have to operate it actually. So maximum 3 months, it will definitely destroy. But if you go for the MS based drum, maybe 3 years. If you go for the SS material, it will go beyond 3 years. But no one is going to the SS or MS by the farmers, because farmers spending small amount of money. If 3 months or 6 months, that is also there enough. Just take it and throw out. They will buy another drum actually.
So this is then 25 batches per month, 3 months. So you're putting at 70 to 75 runs. That's 75
Yes, yes.
months, right? And then I had a question on the lid. If you didn't have the lid, can you still, in this manner, there are other ways to do this, or is this you have to make it fabricated in this
No,
shape?
no, no, sir. This model, whatever biomass, you can make it in the same model drums only. You cannot make different drums for different biomasses.
Okay.
So one single clean, you can make it all type of biomass, leafy materials, straw materials, or in a nutshell, or wood. But only the time variation will be happen. If you put the leaves, it will make it around 30 minutes. It will come to the biochar. But if you put the wood, it will take 2 to 3 hours. That is the time period. But the same clean has been used to all type of biomass, and there is no any electricity also is not required, and there is a very small amount of batches of biomass for burning purposes. We cannot put lot of biomass burning, only small amount.
So when you say small, so what kind
Yes.
of pre-processing are you doing it with wood biomass? Are you cutting it into 2 inch or 3 inch
Yes,
sheets?
yes, because the drum size will be more than actually 5 feet. So you
Right.
have to cut around 3 to 4 feet something inside the wood, inside the drum. So only
Right.
the small pieces is very good for the carbonizations. That's all.
So do you have any recommendation on shredders, using shredders, or are you doing it manually?
Sir, generally we used for small sizes only, because we take corn cob only the small sizes only, no, 15 feet or only 15 centimeters something only. But if you go for any long stems, you have to cut it in the around 10 to 15 centimeter size. That's all. We cannot recommend it, sir. Generally, our MCRC, we cannot recommend it for cost, because each process involved in cost actually.
I
So
see.
we recommend it for the general process only. You can see these are only small only. There is no any bigger material we can use. We cannot use. But if you use the wood material, you just cut it on 15 centimeter or something.
Okay, so when you take this out, are you powdering it? You said you don't want to powder it too fine.
No. We want
What
to
is
powder
your,
it. After making the biochar, we want to powder it definitely.
okay, so how are you powdering it? Is there a
We are using small pulverizer is having some of the producers, but some of the producers not having the pulverizer. We recommended to put the biochar in the road, tar road, that is cement road or something. You just go to the tractors 2 or 3 times, then you can see there is all the materials are could be a powder actually. So just pack it and leave it to the farmers. That's all. Very simple technique also we do.
So the question in this bin was, can I create bio oil? Because I was traveling in some parts abroad and I saw in another Asian country, they were collecting oil from this drum skin also. So have you experimented with that?
Yeah, one of the model I show some pipeline has been put it in the chimney. That is by use you can take the oil also, but this method we cannot take in the open method. That is this type of drum method. When you put the pipeline to the scrubbing method or something, you can take the oil. Not this one. This one also, left hand side also. Yes. This is also we can take the oil also. But we want only biochar. That's why we take biochar. We cannot take the oils actually. But some of the people you told, no, oil is a very good pesticidal activities like
Yes.
that.
Yes.
I also tested some oil has been tested with pesticidal effect. We got a very good results in crops also, but not yet. We are not doing such kind of activities.
So your cost of the drum kin comes to 6,000 to 8,000 rupees, you said, to
So
fabricate.
this is for Tamil Nadu cost. Maybe if you come to Maharashtra, drum cost will be 500. The making cost will be 2,000. Maybe 3,000 also is come down.
Right. Right. So to make the bio oil, I'm very interested in also trying that out. Can we put in the common drum vertical, or like this horizontal is better for bio oil?
I think both we can use it, but when we tried in the vertical method only, we got a very good results actually.
So can we see that? Is there a slide on that, or we don't have that in the slide?
Which one, sir?
The bio oil pipe.
The next one, I think before one or next one.
Division, can you just go back?
Yeah. The next one.
Next one.
Next. This one. This is the method actually.
I see. So
this is the method we developed with the help of some IIT persons. We experimented in the laboratories actually. We can collect some oils and use it for the pesticidal activities.
Okay. And you have not tried much with that. I mean,
we could not try it actually. 1 or 2 experiments only we did actually.
Okay.
But our most core subject is only for the biochar. That's why we not touch this type of bio oil products.
Got it. So if people want to buy the drum kiln the way you have fabricated, can they buy from MCRC, Murugappa Chettiar Research Center, or will you advise them to make their own wherever they are?
No, actually I told him if you buy from MCRC or in the Chennai, because you know that MCRC is a non-profit, we cannot make the fabrication or something. But my recommendation is whatever the biochar that is drum is required, you can fabricate in our local areas itself.
Okay.
Because very, very simple. I have the Hindi version of fabrications. I have the English versions or Tamil versions. If you want, I can share with you. If anybody interested, they can make it very, very easily in the local peoples. Any welder can do.
Got it. So, Bibhishan, you can go back to that slides where they were showing the parameters of biochar. Maybe it's ahead. So there you had used the term organic carbon and fixed carbon.
Yes.
Can you explain that little more, because I got confused there. What is the organic carbon in the biochar that is produced and the fixed carbon?
Sir, actually, fixed carbon and total carbon is almost same. For example, if you take any biochar, the total carbon content around 60-70% is called total carbon. The similar way is called the fixed carbon. In the total carbon, there is a organic carbon and inorganic carbon is available.
Okay.
So that organic carbon is around 20-30% will be there in the 100% of fixed carbon or in the total carbons.
Okay.
You understand? Because, sir, if you take any carbons, there is a 2 type of carbon inside actually. This is organic carbon and inorganic carbon will be there.
Right.
So what I'm told is the fixed carbon and total carbon almost similar. Among the total carbon, you have the organic and inorganic will be there, but I cannot showing this slide. But I have the data actually. We tested 65 now. Each having what is the capacity, how much of organic is there, how much of inorganic is there. We have the data also.
Right. Okay. So you also said that you mixed you mixed it with vermicompost, you mixed it with farmyard manure,
yes,
and you mixed it with urea, but you also had one that said raw biochar alone. Was that just biochar alone without any charging? You have put it in the field?
Sir, the biochar alone, we cannot charge anything, it just apply. But the another method like composting, we have to charge and keep it for 15 days or something, then only we apply.
So you're not.
But our recommendation when we mix it with any materials, organic material, that is a very good results we observed so far.
Right. So
instead of putting instead of putting the raw biochar.
Yeah, Bibhishan, if you can go to that slide, keep going ahead. You had one slide in that farmyard manure and one.
Yeah, photograph slides.
Bibhishan, down.
Bibhishan, next one.
Down. Yeah.
Maybe you can go for. No. Next.
Yeah. Oh, was it? Bibhishan, go to the fixed carbon and organic carbon. No, go back.
Before, yes.
Go a little bit slower.
Yeah, go before urea.
Before urea only, actually.
No, I think it's okay. I think, yeah.
Before. Next one. Yes.
So yeah, the first one, you said biochar alone. So
yes.
does it have anything on it or it doesn't?
Sir, actually this recommended for the worst soil. People are asking, sir, we cannot cultivate it so many years. My soil organic carbon is very, very low. Why don't you give any suggestions? Like that, we recommended this biochar because you know that biochar having the capacity to conditioning the soils. That's why this first one is recommended.
I see. Okay.
The second one is only the most of the crop cultivated continuously. You have to make improvement. We can provide this type of enrichment programs.
Got it.
Enriched biochar.
Got it. Because everybody says you have to charge the biochar. Don't put.
Yes. I'm also suggesting that you have to enrich the biochar. Then only you can apply. You got a good results.
Got it. Vibhishan, do you have any questions from social media?
They just put in message.
Okay. We also can take questions from people here if anybody wants to unmute and ask.
How much soil carbon increase?
Over the period of applications, huh?
Lakshmi Narayan Rathi asks, how much soil carbon increase happens? And also, I think, cost per acre.
Sir, when we applied 500 kg or 100 kg for biochar application, they cannot improve within a year immediately for soil carbon improvement. But when we go for the soil, biochar alone, 5 tons per recommended, it will give minimum 0.5 to 0.6. That is only 0.1% will be maximum increased. But the over period of application continuously for 3 to 4 years, then only your organic carbon level will improve. They cannot do immediately because everybody know that biochar is not a fertilizer. They cannot give the immediate result to the crop. Only the soil health program, so soil health management program, generally it will provide at least 3 years continuously you can apply, then you can see the results.
Interesting. So could you also talk a little bit about your organization, your team, the size of it, who all works there?
Yeah. Actually, our research institute having the maximum is around 45 to 50 people. And most of the people are scientific people like biotechnology, microbiology. Some of them are engineering persons available. And apart from that research activities, we do a lot of rural-oriented projects like CSR implementation. Then only we can do solar water pumping system, cold storage system, especially you know that phase change material, PCM-based cold storage materials, solar dryers, and smokeless chulas. So a lot of work is going on with rural application, community development, something like livelihood programs.
Amazing work just in biochar alone.
Yeah. Biochar, apart from biochar, we have some liquid fertilizers also. Like you know that humic acid has been produced by the coal something, lignite or something. Generally, humic is extracted from the lignite only. But our method is we cannot take the lignite, we can use it for the organic material. There is a organic product that's been converted into fermentation process. Then we can extract the humic and fulvic acids. Because you know the humic and fulvic is very good for the rooting for plants and also flower setting. Because most of the crops or flowers are fall down now. This will be setting the flowers and don't fall on the flowers like that. It will be the very good results.
Any trials that you have done?
The similarly same biochar what we do, no, same similarly humic acid also did. And you know that panchakavya, actually most of the people know panchakavya is the 5 different ingredients they used. But our panchakavya is nothing is different from the normal panchakavya. Because we used one of the bacteria is called the methylotrophicus bacteria that will enhance the productions by IAA and IBA and also reduce the fermentation period because most of the panchakavya is produced by 20 to 25 days fermentations. But our panchakavya is within 15 days by using our bacteria. That is methylotrophicus bacteria. We just added and fermented within 15 days. You can see the comparison when we normal panchakavya and our panchakavya, that is fortified panchakavya, that the growth hormones is very higher. That's why we recommended this fortified panchakavyas also.
Is there any way for someone to make large quantities of these?
Yes, this large amount of humic and panchakavya also they can do similarly what we did, 500 tons like that. We created entrepreneurs. They will do yearly around 1,500 liters or 2,000, monthly basis 1,000 liters. In the yearly basis, 10,000 also we got actually humic and especially for fortified panchakavya also.
So we have to have you back because there are so many interesting, topics here that we'll have to have you back because you've done so much work and all these.
No, apart from that, we do a lot of plant biopesticides also we do. Right. There are a lot of activities going on actually. Plant biopesticides. By using 4 different oils actually, we can control the pest and disease also. If we do not only for the plant oil, we also use some plant leaves also.
Tejas, I think we have to take some questions. I think I'll just say that if anybody wants to ask a question in Hindi, they can. अगर हिंदी में कोई सवाल पूछना चाहते हैं वो पूछ सकते हैं, हम लोग ट्रांसलेट कर सकते हैं. तो किसी को कुछ सवाल है तो प्लीज अनम्यूट करके पूछिए और हम लोग ट्रांसलेट करेंगे.
I think some of them are showing the hands, I think.
Yeah.
भानुदास पूछिए।
सर जी, तेजस सर जी, मेरा आपको क्वेश्चन ऐसा है जी कि बायोचार, रॉ बायोचार, चार्ज बायोचार या सब वो सॉइल खेत में डालने के बाद उसका सॉइल टेस्टिंग कितने दिनों के बाद कर सकते हैं? उसमें अपना बायोचार का इफेक्ट रिजल्ट कैसा आ रहा है, ये कितने दिनों में अपन पीवीके के थ्रू करके तपास वो ये करके अपन उनका कोई ऐसा सर ये मिल सकता है क्या सॉइल का टेस्टिंग का, कि अपने खेत में अपन इतने दिनों से बायोचार डाल रहे हैं, इसका इतना ये आ रहा है? ऐसा मेरा प्रश्न आपको समझा कि नहीं समझा?
हाँ, बायोचार सॉइल में डालने के बाद कैसे और कितने दिन में उसका रिजल्ट दिखेगा, आप उसके बारे में पूछ रहे हैं।
What is asking, sir? I am sorry.
हाँ सर, वो
So, sir, Banu
sorry
is
sir,
asking, once we put biochar into the soil, how can we measure what's changing? What parameters should we look at, and what can we measure some of those?
Actually, when we apply to the biochar, you cannot see the visibility of the soil or something, because you are applied very minimum quantity of biochar to the soils, especially for the when we mix it with urea or in the compost, maybe around 100 kg or 500 kg, like that only we apply, because 1 acre is a very large area. You cannot see, but when we see the crop yield and crop growth, you can see the differences actually. When we go and do the experiment with the farmers, we provided first you can do with whatever you do practice, you can do the small part. The another part, what we do, our methods, you can reduce the biochar or you can put the biochar, you can see the differences of crop cultivation. Then after taking the harvest, we can take the soil sample, analyze, you can see the differences also. That kind of experiment only the farmers can understand. But visually, when we see soil is good or something, you cannot take immediately actually.
What according to you is a good soil test? The people that do to soil tests everywhere, but how do you test yours?
Definitely, if you put the soil test in every 6 months once or the yearly once, it's very good actually. But you want to know the carbon, because you know all of us, the organic carbon is very important. If organic carbon is more than 5 or 1, any putting the chemical fertilizers, it will take it to the crop and grow. If not organic carbon not available, no, if you put any urea or DAP, definitely the plant will not grow, because organic carbon is the base material for crop cultivations. That's why I'm telling each farmers you have to test the soil organic carbon level, because each year most of the farmers they aren't putting any organic. Organic carbon is coming from two different ways. One is the organic materials for farmyard manure or something, or some people are cultivating the green crops, green crops or the tangy or something. Because in older day they put lot of cow dung, but now no one is using the cow the farmyard manures. That's why the declining of soil organic carbon level and all the crop yield also is decreasing due to this. That's why we recommended why don't you use this biochar, because biochar have the reclamatic carbon, it will long lasting. Because generally if you put biomass to the soil, bacteria will degrade the material biomass, it will produce CO2 or something, they will use small amount of organic carbon to the soil. But if you go supply to the biochar, the bacteria will not degrade it very easily to the carbon, because it's a dynamic structure of carbon. They cannot easily degrade this material. That's why we can put the biochar with longer years, at least 25 to 50 years. It is remain in the soil and give the very slowly development of the soil health programs.
The one last question at the cost of repeating, how does the flame travel in this drum kiln? Like it starts from the bottom. How is the air and flame traveling?
So
Sorry, Sachin, you had a question.
Tejas, you might have to translate it back to Hindi.
Okay.
Because you forgot that. All right.
You can inform actually, yes.
Yeah, finish that thought with the soil
Maybe
test.
he's waiting.
Yes. Okay. वाशिम सचिन को भी पूछने देते उसके
अरे
बाद
भूल जाओगे आप, फिर सर ने बहुत बोला है आप भूल जाओ।
ट्रांसलेट करता हूँ। हाँ, सचिन पूछिए आपका सवाल।
सर मेरा नाम सचिन है, मैं वाशिम से बात कर रहा हूँ। तो मेरा एक क्वेश्चन था, जैसे मेरे पास अभी 2 एकड़ जमीन है, तो अगर मुझे घर पे बायोचार बनाना है तो मुझे क्वांटिटी किस साइज का चाहिए और वो कहाँ से मुझे मिलेगा?
I think I understand the 2 acre of land is having. Is asking quantity or something. What is the drum he is asking?
How to make his biochar if he has 2 acres of land. I think Sachin is also a mulberry farmer. If I'm
Sir, very good actually. One of my farmer is cultivating mulberry because after cutting the mulberry, you put the leaves to the worms. There is a stalk is there, stems is there, no?
Yes.
They can make it is a biochar, is a very good biochar. We also tested. If you want, I can share the results also. Very good carbon content is there. If anybody is cultivating mulberry, is a good carbon material. Definitely, you can make it small drum. Whatever I show you, the 200 liter soil drum, you just make it and you can use it for more than 500 kg per seasons. I recommended this mulberry plant material is a good carbon materials. So one of the
सर
farmers in our yes please.
मेरा और एक क्वेश्चन था। जैसे सर आपने कहा कि फंगस और माइक्रोब्स के साथ हम इसको चार्ज कर सकते हैं, तो चार्ज करने के बाद वो अच्छा रिजल्ट भी देगा। लेकिन मेरा क्वेश्चन था, जैसे हम जब फंगस और माइक्रोब्स यूज करते हैं तो उसके साथ कुछ अनवांटेड बैक्टीरिया भी उसमें जा सकते हैं क्या, और उसका कुछ साइड इफेक्ट हमारे खेत में हो सकता है क्या?
He's asking the biofertilizer mixing with biochar.
So when composting or co-composting, how do we reduce the unwanted fungus and bacteria, basically the pathogenic microbes?
Actually, we cannot eliminate this fungus or pathogens in during the mixing because we don't know what type of bacteria will be available, what type of fungus is available. So, but most of the soils having microbial populations having good bacteria, but some of the soils having some pathogens also is available. But we cannot take out from this fungus or any pathogens. It is very, very difficult actually. We cannot do like that. But we recommended we can use it for biofertilizers when we mix it 10:1 ratio. For example, 10 kg of biochar, maybe we can put 100 gram of biofertilizers like phosphobacteria or pseudomonas or something. It will give the very good, it will enrich within a week. Then you can apply to the soil. It will give the very good results. Like that, we recommend it mostly.
Start with good bacteria.
Yes, but we cannot take for the because I don't know what type of pathogens available because most of the soil farmers using the good bacterial population to increase the good bacterial automatically they will destroy. That is our motto actually.
Sachin, और कुछ सवाल?
हाँ, और एक मेरा क्वेश्चन था सर, जैसे मानो हमने बायोचार हमारे खेत में डाला है और हम जैसे तणनाशक का यूज करते हैं, तो क्या तणनाशक भी बायोचार में वो चार्ज होके रह सकता है क्या?
So let me translate that. He's saying we're using weedicides. If we make a weedicide residue in stocks, will that show up in the biochar as well? Because the biomass has the weedicide on it, when we spray weedicide.
So, okay. He told that weedicide is be present in the biomass itself.
Right.
Then make it to the biochar. They will having the pesticidal residues. He's asking.
Yes. Will the final biochar?
Yeah, sir. Generally, when we apply the pesticide in the soil or the plant, it will remain at least 6 months to 1 year. Okay, that's why people are told don't use the harmful pesticides to the soils of the plant. But when we make it with the thermal material, because if you put the 600-degree, maybe it will be degraded. Okay, maybe a lot of bacteria will be degraded. Similarly, the pesticides also degrade because most of the pesticides or the other materials withstand only the
also they can break down.
Because the compound also break down because 500-degree its temperature is very high at temperatures. Definitely they will not withstand actually. When we converted biochar, it's a very good. But if you put the raw biomass, it's very, very dangerous.
तो सचिन, पायरोलिसिस में सब वो जो है वो 600 डिग्रीज में पूरा ब्रेक डाउन हो जाता है, वीडीसाइड का जो भी इंग्रेडिएंट्स है।
नहीं, ब्रेक डाउन होने के चांसेस अच्छे हैं।
The compound will be definitely degraded actually.
Right. So
nice question.
Tejas, you want to translate Banu's soil test? You still haven't.
Yes, बानु जी, तो सर एक बोल रहे थे कि वी हैव टू मेजर करते रहना चाहिए, हर साल में एक बार मेजर करें तो अच्छा है। और बेहतर तरीका नोटिस चेंज करने के लिए कि पहले आप एक पौधा विद बायोचार कंपोस्ट, एक पौधा विदाउट बायोचार कंपोस्ट लगाइए और देखिए रिजल्ट्स। और उसके साथ एक्सपैंड करने के लिए बोल रहे हैं। और सॉइल टेस्ट हर साल एक बार करना चाहिए, बट ये जानना चाहिए कि क्या टेस्ट कर रहे हैं, क्यों टेस्ट कर रहे हैं, उसको कैसे मूव कर सकते हैं, कौन सा इंपॉर्टेंट है, कौन सा वैल्यूज इंपॉर्टेंट है, इसमें थोड़ा समय भी बिताने के लिए बताया। तो हाँ, साल में एक बार सॉइल टेस्ट कर सकते हैं और इस्तेमाल करके देख सकते हैं कि किसी में पेड़ में अच्छा आ रहा है, अगर नहीं इस्तेमाल किया बायोचार तो वहाँ पर ग्रोथ कैसी है, फ्रूटिंग कैसी है, फ्लावरिंग कैसी है। सो देखते हुए भी आगे बढ़ने के लिए बोल रहे हैं सर, एंड साल में एक बार टेस्ट तो कराने के लिए ही बोल रहे
लेकिन
हैं।
तेजस ये भी बोला था कि सॉइल ऑर्गेनिक कार्बन होना चाहिए,
सॉइल
सेंट्रेट कार्बन
ऑर्गेनिक
होना
कार्बन
चाहिए।
बहुत
हाँ, सॉइल
इंपॉर्टेंट।
ऑर्गेनिक कार्बन होगा तो ही ये सब का इफेक्ट होगा, नहीं तो फिर नहीं होगा फिर।
आई थिंक रूट्स और सम ऑर्गेनिक मैटर दैट इज बीइंग लेफ्ट आजकल फार्म्स में, मतलब जड़ है जो छोड़ा जा रहा है फार्म में, बाकी सब काटता है या नहीं तो जलता है या नहीं तो कहीं और चला जाता है। रूट समटाइम्स दे आर लेफ्ट टू डिकम्पोज दे राइट देयर। तो काफी कम होते जा रहा है। तो कवर क्रॉप्स प्रॉब्ली मोर इम्पोर्टेंट है। देयर कैन बी सम इजी वे ऑफ ऑर्गेनिक मैटर आने का। यस, इफ वी कैन ब्रिंग इन वर्मी कंपोस्ट, गुड। भानुदास एक्चुअली एक बायो इनपुट रिसोर्स सेंटर चलाता है सुगमारन सर।
Okay, right. In which district, in our locations?
महाराष्ट्र,
Maharashtra, okay.
अकोला,
बुल्ढाना।
बुलढाना।
Okay.
सर एक मेरा क्वेश्चन एक और है कि जो अपन ने जो आपसे बायोचार लिया वो मैंने डाला है, जो आपने बोला बायोचार का, तो बायोचार का इतना अच्छा, आधे में रिजल्ट इतना अच्छा दिखा है कि नींबू लेमन इतने चालू है उसके, मैं आपको उसके फोटोग्राफ भी डाल सकता हूँ। बहुत ही क्योंकि आधे में एकदम मैंने मेरे सबने लेबर ने सबने भी देखा है कि उसको कितने लेमन लग रहे, और आधे में बहुत, जैसा तुमने बोला एक पौधे को डालो एक पौधे को मत डालो, उसका रिजल्ट देखो, तो मैंने उसको चार्ज करके जो डाला उसका बहुत रिजल्ट इतना अच्छा दिखा कि वो झाड़ भी मरना, जो उसका जो मरना था वो रुक गया। लेकिन जो उसमें अपना जो मेरा पहले से मेरा ऑर्गेनिक है, एकदम 100% ऑर्गेनिक है, 10 साल से मैंने उसमें केमिकल कुछ भी नहीं डाला, इसलिए मेरे को बायोचार का इतना अच्छा रिजल्ट दिखा, क्योंकि वो जीवाणु उन्होंने पकड़ के रखा, ये मेरे को समझ में आया। लेकिन अब मैं जो बोल रहा हूँ कि अभी बायोचार मैंने आपसे लिया, उसका मेरे को रिजल्ट अच्छा दिखा, लेकिन अभी जो मैं बायोचार बनाना चाहता हूँ, तो मेरे पास जो बायोचार बनाने के लिए जो जड़ पेड़ जो भी है, तो लेमन के ही है, जैसा लेमन जो सूखते हैं जो उसका ही बना के, उसका उतना जैसा आपने मेरे को बायोचार दिया उतना वैसा उसका इसका भी रिजल्ट आएगा क्या, ये मेरा क्वेश्चन है सर।
आएगा, शुरुआत में इतना अच्छा बायोचार नहीं बनेगा, बट धीरे धीरे करके उससे भी काफी अच्छा क्वालिटी बायोचार आप बना सकते हैं भानुदास जी।
What is asking, sir?
Yeah, question
He's
is
saying he got some good quality biochar from some place and he used it and
Hmm.
he's seeing good results.
Hmm.
But if he can make his own biochar from his tree cuttings, lemon tree cuttings, can he expect the same results?
Yes, exactly. Yes, definitely you got the same results only. Because depend upon the carbon, the surface area and pore structure will be play a major role in the biochar. So maybe definitely they will use for their own biomasses or any wood material. It will give the good results only.
So the industrially pyrolysis
Paralysis.
produced biochar, they're saying 84% carbon and very high percent carbon. Whereas what we are, I mean, from your slides, it seems we are in the 50 to 60% range. So,
Sir, actually, that's why I'm telling when we use the different techniques actually. Because some of the continuous process techniques, they will not use any oxygens. Maybe it will increase the fixed carbon, that is carbon content, definitely. Because we used different raw materials actually. If you put the coconuts also, you can get more than 80%.
I see.
Because when you use the maize cob or leaves material something, only less, when you use the different material, definitely each having some different organic carbon, that is fixed carbon content only. They
Right.
cannot all the carbons come to the same level.
Right. So, but the insight for me was also from the quantity comparison to the drum. You said the drum produces higher quality than the quantity, and that was definitely a lot.
No, not I'm telling for the same cost, the same fixed carbon only. Because maybe the quantity is 60-70% of the carbon content.
Okay.
Similarly, ours is 50-60% of the same carbon content only.
Right.
So I cannot say quantity is low and ours is best.
Right. No, I know. But when we heard from people to learn the quantity to do it properly, because you're layering it.
No, actually, quantity is very, the labor expensive method actually.
Right, yeah.
You have to stand and watch the quantity putting layer by layer. But our method, we just fill it and go for. Only the first time you have to stand is the time actually. If you put maize cobs, you can see within 45 minutes. The next batch, you just put it, you go for any work, then you come to the, after 45 minutes, you just sprinkle, take, everything will be ready. That is the way, because farmers wants very easy method only. They cannot stand, they're putting layer by layer, they cannot go for any work actually.
Right.
That's why I recommended our method, because both the carbon or something is almost similar only. Only these are the small issues when you use it for quantity and but the flame that fumes also come out from our drum metals slightly higher than the quantity.
Right.
Quantity is because in the flame curtain techniques, when we come to the flame that is smoke, immediately the burning will happen. But our method, they cannot burn the smoke actually. It will come out actually.
Are there any techniques where it can be simpler and not labor expensive, but with lesser emissions? Have you tried anything?
No, we tried a lot of small techniques, but economically are not feasible. That's why we selected this small drum method actually. But it will come some small amount of smoke definitely will come out from this method actually. That is the difference with, because quantity is recognized by the carbon credit labels.
It's all stacked inside. There's a small door on the bottom. We light the first thing, and then once the fire has started,
fires happen, because in the fire portion there is a small grill is there, because the grill only they can hold the biomass.
Yes,
this is the grill.
Yes,
then put the biomass is holding the biomass, but above the grill there is a burning will happen. This burning will touch this biomass slowly. Within 5 minutes they will go immediately like this. Then we please close the door, all the doors. Then it will happen the paralysis whole biomass, and we can see that the lid, there is no any smoke will not coming. The product is ready. That is the indications.
So is there a phase where there is more smoke initially and then the smoke reduces?
Yes, exactly. Yes. Initially we start with higher smoke, then slowly come down actually. Okay. Then you have to see the differences also. First time you can see the dark brownish smoke, then you can come to the white, then there is no any smoke, only the waves will be, the heat waves will be there. That is a heat wave means there is already biochar is happened. The biochar itself giving the energy. That's why the wave is happening in the heat waves. The lid actually.
Sure. It's interesting. I mean, that's where.
That's why I'm telling Anand sir, we will do one small trial in our place actually. You can see, you can popularize in anywhere actually.
Right.
Maybe next session we will love to see a video and then visualize how the.
Yes. I can share some of the videos also available. I can share with you also.
Right.
Wonderful.
Tejas, we're out of time. You want to conclude, because we are way over time. We didn't even realize it.
Yes. Many closing comments from you, Anand.
No, we want to have you back. That's all I want to say.
Yeah. Please come and we will discuss it directly also.
Yeah, I can see like 15 topics in your presentation.
last question. सर एक लास्ट क्वेश्चन सर मेरा, कि अपन क्वांटिटी ड्रम इससे अपन बायोचार बना सकते हैं, तो सब उसके नहीं तो मिट्टी का जो अपन जो बनाया दो, उससे भी बायोचार अच्छा आएगा क्या?
Sugumaran ji, Bangladesh made a brick kiln also, and he has made biochar in that. So he's asking, how does that compare to this?
Sir, brick kiln or mud kiln or everything is almost similar pattern only, because this pyrolysis techniques, when you reduce the oxygen content, you can make the biochar. If you put more oxygen, only the ash content will be coming. I mean, so then you can make brick kiln or metal kiln or any kiln, you can get good same biochar, only the carbon contents slightly variation will be happen. That's all.
There is one other bubble out there, the carbon credit money.
Yes.
We have
people are not, but
in this conversation yet.
But if you go for this drum method or the soil method, they cannot take it for the carbon credit. But because I talk to a lot of carbon credit people, why our method is not giving the carbon credit. They told, because in the Kontiki method, the flame curtain technique has been the smoke will be burned immediately. But our method, the smoke will, no, if you reduce the smoke, we will accept for the carbon credit.
You can probably bring all that smoke back.
Maybe if you put some of the techniques, definitely arrest it, but the cost will be higher.
Did you just try bringing the smoke back to the bottom?
It is possible, but the cost wise is not good for the farmers. So we think only for the farmer point of view, maximum.
Interesting, sir. It'll be very nice
They
to.
just
Haji.
they just check the put box, chat box.
Yes. Mr. Maheshwari from Ahmedabad developed black gold rupees 1.5 lakh per annum, I guess. Soil carbon raised 2.0 in 3 months.
Yes.
If you apply 5 metric ton per acre, how much raised soil carbon in 6.5 months?
Sir, I told him already the same questions. If you put the 5 tons per hectare, maybe 0.1% will be increased. Because if you put continuously for the year, you can see the differences of the soil organic carbon. Because immediately, definitely, any soils cannot improve the organic carbon immediately. Actually, it will take time, definitely.
So biochar has a lot of potential. It has
Yes, 100%.
it has the house, but the microbes have to come in, start living there, start populating the place.
Yes.
Each and every nanometer or nano has to be touched by a microbe or a nutrient to realize its potential. Wonderful. Sir, Sugumaranji, thank you very much for taking out the time, firstly. It's very interesting conversations. You have definitely done a lot of things here. You have started your journey way before any of this cloud has taken shape, the carbon credit cloud. So you come from very decentralized, farmer-centric, farmer first, not worrying about whether some cherry on the top is the initiating point for soil journey in soil health as well as journey in waste residue management. I think you're very well laid out how much waste is being generated, how much of it is being burned, and then we went into different crops. And I think you're working with farmer centric feedstock. That's why there are also low bulk density feedstocks also in your every slide, I think, deserves a 20-30 minute discussion out there. So,
no, lot of data is also, if you show that all data, most of the people are going beyond the time actually.
So we would love to have you back. This is wonderful, real overview of what MCRC has done in decades. While there are some very enthusiastic, very curious minds who have, more and more minds are coming into regenerative agriculture and everything. So it'll be very nice for them all to learn from your experience and live that early and see that happen, especially in biochar, because it's just such a new term that is coined, new term that is hyped up. It's the same charcoal in some different way, used for something else, measured in some other way, and everything. So we would love to have you back. Maybe we can create a mini series in itself.
Sure, definitely. So I would like to thank Anand sir, because we talk about more on many days. Normally it's happened coming to the seminar level. So I'd like to thank both of you for giving a wonderful host actually. Thank you so much for giving the opportunity, sir. So we'll meet you on Chennai actually shortly.
Could you please recite maybe your contact number and email for our...
Yeah. I can. My number is 9444 767 419. This is a phone number with a WhatsApp number. So anybody wants clarification or in the advice or in any making of claims, you please contact me through WhatsApp or the phone call. Definitely, I can help you anytime or anywhere.
Wonderful.
Any locations also. Thank you so much, sir.
Thanks a lot, Sugumaran, sir. It's been a pleasure. I'm sure whoever watches this will go through your decades of experience.
Yes, sir.
Love to have you back. And
thank you,
everyone watching. We try to bring people like Sugumaran Garu and in the biochar world come share their experience. The hope is to do this every Saturday. Sometimes we miss, sometimes we come back.
Yes.
And we'll continue to do this and have this conversation going along. Thank you. Stay tuned and we'll meet another Saturday.
Thank you, Shekru. Thank you so much, sir. Thank you. Bye.
Thank you, Anand.
Thank you.